In this video, we can discuss about program relocation. Program relocation. Relocation means changing from one location to another. So normally after assembly, the object code is created and the object code will be loaded at the starting address. For example, starting address is given with the start statement. Suppose it is 1000. So the program has to be started loading from the address 1000. Sometimes the memory may not be free. The location 1000 may not be free because we have to run several programs at the same time. So if this starting address 1000 is not free, it will load into some other location. So this absolute program means in this, the address is mentioned during assembly itself. For example, the starting address is mentioned in the assembly itself. Consider the instruction LDA3. So LDA3 means load accumulator with the content of this location, memory location, this operand. Operand is 3. And the operand, that location is, for example, in this case, 102D. This statement says that the register A is loaded with the value stored at location 102D. Suppose it is decided to load and execute the program at location 2000 instead of the location 1000. Hence, we need to make some changes in the address portion of the instruction so that we can load and execute the program at location 2000. If the starting address is changed, instead of 1000, if it is 2000, then this memory address of this label 3 will also change. So some information has to be given in the program. Assembler don't know where the actual location of the program, that is where the starting location of the program in memory. It is known by loader at the load time. But the assembler can include some information for the loader. That is, the assembler identifies for the loader those parts of the program which need modification. An object program that has the necessary information to perform this kind of modification is called relocatable program. So the object program contains some information for relocating. This diagram shows the concept of relocation. In this, each block represents the memory. So consider the first block. In this, the starting address of the program is 00. If the program starts from 00, then consider only one instruction plus J sub RDREC. This instruction is at location 60006, and the operand of this instruction, which is RDREC, the value of RDREC is, which is a memory address 1036, which means RDREC is defined, the address of RDREC is 1036. Suppose if the program starting address is changed to 5000, which means the program is relocated to another location. Maybe this location is not free, so it is relocated and loaded into another location, for example, 5000. Then this instruction will be 5006, and RDREC, the value is, for the RDREC label, the address is 6036. So in the instruction, that change has to be made, 6036. If it is still 1036, means it will be 1036 somewhere here, it will be a different value. It should be 6036. So the starting address is added to this one, and we'll get this 6036. So this instruction 4B 101036, this part which deals with the address changed. So with relocation, the address part of the instruction changes. Again, suppose it is relocated to another address. This program is relocated to the starting address 7420. Again, this value, this RDREC value gets changed. So this time, this will be added. This RDREC current address is written here. So according to the changes in starting address, some instructions which has operand as direct addresses, that will change. So that change we have to show in, the assembler has to show in the object program. Then only the loader can load accordingly. The only part of the program that require modification at load time are those that specify direct addresses. For example, format for instructions. So we have to understand that in a program, in an XC program, all the instructions of the program do not require modification, which means while the program is relocated, all the instructions are not affected. Only the instructions which contain direct addresses as operand, for, as it is in format 4 instructions. Only such instructions require relocation, relocation as modification. So here the other instructions like immediate addressing, the immediate value is given. There is no memory referencing. So then again PC relative, relative addressing such as PC relative and base relative that also do not require modification, because in such instructions the operand field, it is not an address, it's not a memory reference or a memory address, it is displacement, which means displacement relative, that is target address is calculated by this displacement. If it is PC relative means plus content of PC, then base relative means content of base register. So that depends on content of program counter and content of base register, do not depend on the memory, not referencing the memory. So only the format for instruction needs modification. So the assembler produces a modification record to handle this. So assembler has already header record, text record, and end record in the object program. So one more record can be introduced in the object program as the modification record to store the starting location and the length of the address field to be modified. The command for the loader must also be a part of the object program. Like other records, modification record also has a format. This is the format. Column 1, M is written. Then column 2 to 7, starting location of the address field to be modified relative to the beginning of the program, which is given in hex. Then column 8 to 9, length of the address field to be modified in half bytes. So this is the format for the modification record. So every format for instructions, we had to write the modification record. So we can see one example. Consider the instruction 0006. This, the instruction is at location this 6. Then C loop plus J sub RDREC. The object code for this is plus sign, means it is format for instruction. So while relocating the program, this address changes. So this instruction needs modification. So we can write the modification record using this format. So first M is written, then this J, so this is the object code for this instruction 4B101036. In this 20 bit, last 20 bits is the direct address. Last 20 bits means this is one. Last 20 bit means this is 4 bit, then 448, then next is 12, then 16, then 20. So from here 01036, this is the part of the address. This field, this address field only requires modification in this instruction. That is from address starts from 01036, that is 20 bit length. 20 bit means it is how many bytes? 16 bit means we can tell that it is 2 bytes. Then 24 bits means 3 bytes, but 20 bit we cannot, it is like 2.5 bytes. So that is not a good format to write in 2.5 bytes. So it should be in whole number. So what we'll write is the length of the address field to be modified is written in half bytes. So 20 bits means how many half bytes? It is 5 half bytes. 5 fours are 20. So half byte means 4 bit. So how many half bytes are there? 5 half bytes are there. That is 5 4 bits are there. So the length of the address field to be modified in a format for instruction will be always 5. That is, that length is written here in the column 8 9, that is 0 5. And here what we have to write is the starting location of the address field to be modified. Where is the starting location? This one, this 0. This 0 is at which memory location? The address starts from 6. 6 means one instruction. This is a format for instruction. 4 bytes it will take. So starting from 6, the first byte will take the address 6. That 4B will be stored in address 6. Then 10 will be stored in address 7. 6 plus 1 7. Then again next 10 will be stored in 8. Then 36 will be stored in 9. So this 0 is in which address? This is at location 6, memory location 6. This is 10 is at location 7. So this 0 is in the location 7. So that is why we have written the starting address here as 00007. That is starting location of the address field to be modified relative to the beginning of the program. So that is, this is the object for this instruction. And in this instruction, what all things we have to write in modification record? First, you have to write the M, then starting location of the address field to be modified. So this is the address field to be modified, 01036. Where it is, what is the starting address of this 0? That is 7, because this is in 6, this is in 7. So the starting address comes in the memory location 7. So we have written the starting address as 7. And length in half bytes. Length of the address field to be modified. This is the address field to be modified for a format 4 instruction. The address field is always 20 bit. So 20 bit in half bytes, if we represent in half bytes, means it is 5 half bytes. So this value will be constant for every modification record for format 4. That is 05. Thank you.